In this class, we are going to see about the various types of antennas based on their major three criteria, which are all physical structure, frequency ranges, and mode of application. So, depending upon the physical structure, it can be classified like wire antenna, aperture antenna, reflector antenna, lens antenna, microstrip patch antenna, and array antenna. This is a pictorial representation of wire antenna, where the single lengthy wire can be made in different form, like dipole antenna with a twist here, and the circular loop antenna and helix antenna. Here these two applications, here this is the long wire which is used for household application, and this is the lengthy wire which can be used for the telecommunication application. And this is the form of the different types of the aperture antenna. What is the meaning for aperture? When we do the when the electromagnetic propagation is transferred from guided to unguided, just like that we cannot be able to transfer from guided to unguided. So there is a gradual change in the there should be a gradual change in the velocity of propagation. So in order to do that, we have made some tapping or some shape like that, like a cone, horn, like that. So these are all called as the aperture, right? So there are plenty of aperture type antennas, and this is a form of the reflector antenna, where we can have the household application of TV reception by using this dish antenna. This is a diagram which explains the transmission structure of the reflector antenna. Here we have given the input excitation, and this input has been reflected incident on this hyperbola to concave reflector and gets reflected, and the reflected wave has been captured by this parabolic reflector. This is the way the dish antenna has been worked. And this is the different form of the lens antenna, and this is a patch antenna, microstrip patch antenna. Nowadays we have used in most of the wireless communication applications. So in here, in this microstrip patch antenna, we have three different platform, that is ground, substrate, and above the substrate you'll be having the patch. So by having this patch in different shapes, the antenna can exhibit the different types of characteristics with the input excitation that is given through this feed line. This is a rectangular patch antenna, this is a S-type antenna, this is a front view of S-type and back view of S-type with a SMA connector for taking the measurement. And this is the type of the array antenna. What is the purpose of array antenna? If suppose the performance given by the single antenna is not that much level, not in the desirable level, and if you want to increase the performance in terms of gain, directivity, etc., you can have the array of similar antennas in any form. It can be of 2 cross 2, it can be of 3 cross 3, or it can be of 2 cross 1, or it can be of 1 cross 2. So by having the array of antennas, by having the combination of more than one antennas, we can be able to increase the performance of the individual antenna. This is the another classification of antenna based on the frequency range. So these are all the frequency range that is given by the IEEE spectrum, starts from very low frequency up to radio wave, and this is the low frequency application antenna, where it can be used for seashore and marine seashore applications. And this is the low frequency antenna, where we can have the telecommunication application. This is a medium frequency application which can be used for hill station, and this is a high frequency application. It can be used for air and space communication. This is a very high frequency application, examples antennas, and this is for ultra high frequency application, which can be the microstrip patch antenna. And this is the example diagram which explains the super high frequency antenna application. Of course, this is the microwave antenna which can be used for high frequency gigahertz application, and this is the radio antenna. And the last third category of the classification of antenna is depending upon the mode of propagation. It can be used for point to point communication, it can be used for broadcasting application, where we have the single transmitter and the multiple receiver, and it can be used for high frequency radar and satellite communications also. So here this is the classification of antenna based on the three mode, which is the physical structure, frequency, range of application, and mode of communication. So thank you.